Good afternoon, judges. My name is Sonia,
I'm Anagha.
I'm Rishita.
and our project for the NGN competition this year is called the SmartBin, a sustainable zero-waste energy solution. For the STEM project, we would like our judges to act as the role of investors. We are targeting problem 6 with the goal of ensuring sustainable, dependable, affordable, and efficient clean energy for all. So here in the Silicon Valley, we have been taking measures to be environmentally conscious. But our world as we know it today is plagued with multiple environmental threats. Some of the top concerns stem from failing recycling programs, limited renewable energy sources, and escalating greenhouse gas emissions. Firstly, despite the rising popularity of recycling, many recycling programs in cities across America are failing, with an increasing cost and inefficient recycling percentage. Over 75% of recyclables end up in landfills, and only 65% of aluminum is actually recycled. Secondly, only 11% of the energy consumed in the US comes from renewable sources. Without effective microgrid options, it becomes infeasible to deploy traditional solar and wind energy solutions. Lastly, carbon emissions from fossil fuel power plants are leading to more critical threats, including global warming and dangerous health issues. Our solution targeting these specific problem areas would have a very vast and applicable market size due to the potential to have a huge social impact. Since our smart bin utilizes aluminum cans for energy production, our market size is dependent on the number of aluminum cans used by individuals around the world, which is approximately 250,000 per minute just in the US. Overall, aluminum cans are very commonly used from businesses to households. Thus, we would like to tap into this resource through our project and have our solution deployed at various levels.
So, to combat the problems we just identified, we listed a few criteria and developed a solution that could fulfill these requirements. So, we developed a SmartBin energy system, which takes aluminum cans as the input and turns it into hydrogen, which can then be used as a power source for various entities. The SmartBin units can also be connected to a centralized hydrogen grid. Because our solution is scalable, it is also easily deployed in a variety of facilities. Additionally, the system would be versatile, operating independent of weather and climate. Lastly, cost efficiency and energy efficiency are guaranteed with our solution. For example, the total cost is calculated to be less than that of solar and lithium-ion sources, and 1 kilogram of hydrogen produces 35 kilowatts of energy. So here you can see a representation of how our solution generates electricity from a single aluminum can through the SmartBin. Our idea is to deploy the SmartBin where users can discard their aluminum cans. The SmartBins actually bring the recycling to the user, rather than through a centralized location. Through the SmartBins, you can not only recycle aluminum cans, but also generate energy in the form of hydrogen. Our solution also provides a more efficient, conventional way to recycle aluminum than any other existing solution.
Some potential targets we have for deploying our SmartBin includes partnering up with utility companies such as Silicon Valley Clean Energy, to whom we have already presented our idea to. We would also like to team up with cities and have them implemented in public spaces such as the sidewalk. We would also like to target individual locations that want to go green, such as hotels, casinos, office campuses, gas stations, individual households, airports, stadiums, etc. Basically anywhere where aluminum cans are readily used.
Based on our goals, we have designed a smart bin. It first consists of the preparator, which is the input chamber where aluminum cans are thrown into. Next comes the reactor chamber, where aluminum and water react to generate hydrogen. The hydrogen is then stored in the storage chamber once the reaction is complete. Then, in the collector chamber, the byproduct aluminum hydroxide is contained once the reaction is complete.
So in the diagram shown here, you can actually see the SmartBin being implemented on a large scale. On the left, aluminum cans are converted to hydrogen in the SmartBin. The hydrogen travels to storage tanks and then can be transported to fuel cells to generate electricity. After the process, the electricity is delivered to campuses, households, and even companies.
To put this into perspective, let's look at the 250,000 aluminum cans that are used per minute in the US, which can potentially produce 17.5 megawatt hours of energy and can power up to 15,000 households for an entire day. Now let's look at the 45.2 billion aluminum cans that ended up in a landfill in 2018 in the US alone, which could have potentially produced 3,164 gigawatt hours of energy. It may seem impossible, but this can power all US households for over 3 months or power a big Apple or Google campus for over 10 years.
As you can see in this photo of our proof of concept, aluminum and water react to generate hydrogen, which is then used in the fuel cell to generate energy to power this light. Excess hydrogen is stored in tanks for later use.
Some key milestones we have reached in the process of working on our project include building a proof of concept or a pre-prototype for our SmartBin, as shown on the previous slide, coming up with a detailed, scalable design of our SmartBin, including safety features, presenting our idea to various companies, such as Silicon Valley Clean Energy, the sustainability team at Agilent Technologies, and Peninsula Clean Energy, advancing to an innovation expo hosted by the company Micron, and filing a provisional patent for our SmartBin idea. So there are three main areas in which we would utilize investment money. We have allocated $10,000 for market validation and certification, which consists of checking the validity of the assumptions we have made, market validation and certification requirements. The next area we would target is intellectual property protection through filing patents, which we have allocated $20,000 for. For our prototype, we would like to develop a few smart bins for you to actually put in your household, like in your garage or in your office, with which you can recycle aluminum cans, generate electricity to help power your household through hydrogen from the cans, have hydrogen storage capacity, and include basic sensors like temperature and pressure sensors. For the prototype production, we have allocated a major portion of the investment, $50,000, so our total seed funding comes out to $80,000.
In the first 6 months, we plan to finish all market validation and patent filing. Then, within 10 months, we plan to build our prototype. Within 18 months from now, we plan to have our first customer engagement.
Our plan to attract customers will be to first make a deal with companies, preferably clean energy companies, who can implement the main source of hydrogen that our SmartBin produces. From this, they can provide several distribution channels to other companies that want to go green. We would also start lobbying for clean energy credits. For the second phase of our sales and marketing, we would target individual entities, such as households and companies, who would deploy our solution on a much smaller scale and produce electricity on-site.
We have compared our SmartBin solution, including the hydrogen grid, to our competitors, natural gas fuel cells and solar energy. Our solution proves innovative as it is part of the untapped field of using aluminum to produce hydrogen. For 100 kilowatt peak energy, cost-wise, our SmartBin is a little more compared to solar, but comparable to natural gas. Also, the generation cost for electricity is cheaper than that of natural gas. Also, our solution both produces and stores electricity, unlike solar, which requires an extra $40,000 for batteries. Also, our solution is uniquely positioned to generate electricity from recycled scrap metal and is not limited by geographic conditions and feasibility. Lastly, our solution is helpful to the environment as it releases no greenhouse gas emissions. Again, our solution targets a few key areas of bringing recycling to the edge, generating and storing electricity from recycled matter in the form of hydrogen. It also provides a gateway to the future of a hydrogen grid as both a producer and consumer. We think that you should invest in our zero waste energy system, the SmartBin, for a cleaner, greener, and smarter future. Thank you, and we will now open up for Q&A.
I just have to say, well done, ladies. Very, very well presented, and congratulations on your success so far.
Thank you so much.
Thank you so much.
I will also second that. You guys did a great job. Can I ask a little bit more about where you are with that patent?
Of course. So we have currently filed a provisional patent, and we're working on, after some market validation, we want to file more patents within the first 6 months.
Okay.
Can I understand the dangers of having hydrogen stored? I mean, is hydrogen combustible? I want to just make sure we understand the real costs of having, you know, kind of that distributed model, right, of storing hydrogen in the backs of a supermarket, or you know, of having those kind of mini recycling, you know, bins, as you said, in these locations, if it's office locations. Is there any danger to storing hydrogen that way?
We have factored in several safety features in our bin, such as if things overheat, we would discard the materials completely. So those factor into the price of building the smart bin. So that's why our smart bin can worry about can manually worry about all the safety features. So the user won't have to worry about anything being combustible or